Well, let's take a look at number 10 here in section 5.2. We're going to calculate this integral. Again, your numbers might be slightly different here in terms of the limits of integration, but from -6 to 4, and it's the absolute value of x cubed. So we have to be careful. We just can't integrate x cubed. Here's the graph of y equals x cubed, if you remember that function, right? It's negative, of course, for negative values of x and positive for positive values of x. And so we're not integrating this function. It's the absolute value of x cubed. So what's going to happen? Well, for these values down here of the function where the output is negative, like if I take the cube root of -2, I get -8. But then I take the absolute value, I get +8. So this is going to basically reflect the graph in the x-axis, and it will come up this way instead of that way. So here's what the graph of y equal the absolute value of x cubed look like. Basically, x cubed will be the same as x cubed if x is greater than or equal to 0, but -1 times x cubed, right, if x is less than 0. So we want that negative signed area that we would accumulate on this side to be actually positive signed area. And we're going from -6 to +4. And so we've got, this area here and this area here. We know the final result has got to be a positive value, right? Both of these areas being positive areas. So let's do this. How are we going to do it? Well, I'm going to integrate from -6 to 0. In order to integrate this, I'm going to integrate negative x cubed, or basically just multiply, right? The area I would have gotten here, since it's negative, I'm going to just multiply by -1. And then from 0 to 4, I'll just integrate the regular x cubed function. So here's what it looks like. From -6 to 0, I'll integrate negative x cubed. Again, you can pull the negative sign out, and it's just -1 times that integral. And then add from 0 to 4, right, that portion of x cubed. Antiderivative of x cubed is 1/4 x cubed. Of course, here I get negative. Here I get positive. Plug in 0, I get 0. Be careful. Minus what? A -1/4, and then plug in -6 to the 4th. Well, when I take -6 to the 4th, that's a positive value, right? Raising a negative number to an even exponent, positive, but then times the negative makes it negative. And if you multiply or raise 6 to the 4th power and divide by 4, you get 324. So it's -324, and 0 minus a -324 is +324. Here I plug in 4 and then 0 and subtract, and I get 64. So adding those two up, I get 388. Basically, the 324 would be this shaded in region here, whereas the smaller value 64 would be this shaded in area here. So the value of our definite integral in this case is 388. Hope this helps.